Hello everyone. In this lecture, we will focus on the lessons that can be learned from Jakarta in relation to urban risk mapping and city resilience. Jakarta is a highly relevant case because it represents many of the pressures that contemporary cities are facing at the same time: rapid urbanization, climate-related hazards, infrastructure stress, and deep socio-economic inequalities. Rather than looking at risk mapping as a purely technical exercise, this presentation approaches it as a strategic governance tool. The central question is how cities can use urban risk mapping not only to analyze problems, but also to guide decisions, prioritize investments, support adaptation, and strengthen long-term resilience. Through Jakarta, we will examine how data, governance, participation, and implementation can be connected in a systematic framework. The introduction of this topic begins with a simple but important reality: rapid urbanization and climate extremes create complex urban risks. In many cities, risk is no longer the product of a single hazard. Instead, it emerges from the interaction of multiple pressures such as flooding, land subsidence, infrastructure vulnerability, and social inequality. Jakarta is an especially powerful example of this condition. The city experiences severe flood risk, ongoing land subsidence, and uneven socio-economic vulnerability, all of which intensify each other. In such a context, urban risk mapping becomes essential for resilience planning and disaster risk reduction. The objective of this lecture is therefore to provide a systemic framework that helps cities integrate risk mapping into real decisions. In other words, the goal is not just to produce maps, but to make them actionable in planning and governance. This slide explains the purpose of risk mapping. Risk maps are valuable because they guide spatial planning, zoning, and development control by showing where risks are concentrated and which urban areas require special attention. They also inform infrastructure upgrades and investment prioritization, helping decision-makers allocate limited resources in a more strategic way. Beyond physical planning, risk maps support crisis preparedness and community resilience by making hazard patterns and vulnerable populations more visible. Another important function is that they define data requirements and modeling depth. A city must decide what kinds of risks it needs to model, at what scale, and with what level of detail. For that reason, risk mapping is not only a visual output. It is also a planning process that clarifies what information is needed to make resilient urban decisions. One of the key arguments of this lecture is that risk mapping requires a political mandate. Without such a mandate, maps may remain technically impressive analytical products but fail to influence actual planning or investment decisions. A political mandate ensures that maps shape real decisions across departments and across political cycles. It also creates accountability, which is especially important when several institutions share responsibility for urban planning, infrastructure, water management, and crisis response. Another benefit of a strong mandate is that it helps protect planning processes from short-term developer pressure or politically selective decision-making. Jakarta is used here as an example where mapping was embedded in major investment and adaptation decisions, rather than being treated as optional background information. This shows that risk mapping becomes effective only when it is formally connected to governance and decision-making systems. If a political mandate is necessary, then the next question is how such a mandate can be created effectively. The presentation outlines several components. First, risk mapping should be formally adopted through an ordinance, policy instrument, or council resolution. This gives it legal and administrative authority. Second, an interdepartmental steering committee is needed for coordination, because risk data usually concerns multiple sectors such as planning, water, housing, transport, and social services. Third, responsibilities must be clearly defined, including data ownership, update cycles, and interpretation procedures. This prevents confusion about who is supposed to maintain and use the information. Finally, mandatory publication of risk maps can improve transparency and public trust. When citizens can access and understand maps, resilience planning becomes more legitimate and more accountable. In this sense, an effective mandate is not only formal, it is also organizational and communicative. This slide explains why data integration matters so much. The presentation defines risk as the interaction of hazard, exposure, and vulnerability. This means that a city cannot understand risk by mapping only one dimension. A flood hazard map, for example, becomes much more useful when it is combined with information on who is exposed, what infrastructure is located there, and which communities have limited coping capacity. Without integration, risk maps may be technically correct but operationally useless, because they fail to show the full spatial reality of risk. Jakarta's case demonstrates this clearly by integrating data on flooding, land subsidence, socio-economic conditions, and infrastructure vulnerability. The lesson here is that resilience planning requires a more holistic reading of urban systems. Risks become actionable only when different layers of information are brought together within a common analytical structure. The first major category of integrated data concerns hazard and exposure. Hazard layers may include floods, land subsidence, extreme rainfall, sea level rise, and even heat island conditions. These help planners understand the physical processes threatening the city. However, hazards alone do not define risk. Exposure layers are equally important. These include population density, demographic structure, poverty levels, and the location of informal settlements. Such layers help identify who and what is actually at risk. For example, two areas may face similar flood depth, but the consequences can be very different depending on population characteristics, income levels, housing conditions, or service access. By integrating hazard and exposure, cities can move from a physical reading of danger toward a more socially meaningful understanding of risk. This is especially important in Jakarta, where climate risk and socio-economic vulnerability often overlap spatially. The second data category expands the framework by including infrastructure and community knowledge. Infrastructure layers include transport systems, utilities, drainage networks, and critical facilities such as hospitals, schools, and emergency services. These are essential because disruptions to infrastructure can intensify the impacts of a hazard far beyond the directly affected site. At the same time, official datasets often miss small-scale conditions that residents know very well. This is why community knowledge matters. Residents can identify micro-flooding points, blocked drains, informal water flows, and places where risk is experienced differently from what official maps suggest. Community-based knowledge therefore helps refine formal datasets and makes adaptation more equitable. It also highlights that urban resilience is not built only through technical modeling, but also through engagement with lived experience. Jakarta's case shows that combining formal and informal knowledge improves both accuracy and social relevance. Once multiple datasets are assembled, cities need a common data framework. This slide outlines the core components of such a framework. First, standardized formats such as GeoPackage, GeoJSON, and NetCDF are important because they allow different departments and systems to exchange and interpret data consistently. Second, a central interoperable platform is needed so that all relevant institutions can access the same information base. Third, the framework may include a unified risk index that combines hazard, exposure, and vulnerability into a common structure. This helps decision-makers compare areas and prioritize action. Another key point is the need for multi-level visualizations. Experts, policymakers, and the public do not all need the same kind of interface, so outputs must be adapted to different users. Finally, regular updates are necessary, ideally every 2 to 3 years or after major events, so that maps remain relevant under changing conditions. This slide introduces participatory risk mapping and explains why it matters. Residents often understand micro-conditions that are invisible to models or absent from official records. For this reason, participation can significantly improve both the accuracy and legitimacy of risk mapping. It can also reduce conflict, since communities are more likely to support decisions when they have been involved in generating the knowledge base behind those decisions. Participation strengthens social acceptance because people see that their experiences and observations are taken seriously. In Jakarta, community-informed mapping improved both precision and compliance, showing that technical expertise and local experience are not opposing forms of knowledge. Rather, they are complementary. Participatory risk mapping therefore supports not only better data, but also better governance. It helps transform mapping from a top-down analytical process into a more inclusive and trusted resilience practice. The presentation then moves to practical participatory methods. Mapping workshops can be used to identify flood points, blocked drains, informal paths, and localized conditions that affect exposure and evacuation. Surveys and interviews can reveal risk perception, coping strategies, and even attitudes toward relocation or adaptation measures. Another useful method is the participatory validation of model outputs. This allows communities to review official results and comment on whether they reflect actual conditions on the ground. Stakeholder involvement should also go beyond residents alone. NGOs, schools, hospitals, and utility providers all hold valuable knowledge about how risks affect daily systems and services. These methods are important because they broaden the evidence base of resilience planning. They also help connect technical assessments with social realities. In this way, participatory methods make urban risk mapping more grounded, democratic, and operationally meaningful. This slide explains more specifically how participation improves accuracy. One contribution is the identification of informal infrastructure and microflows that may not appear in official spatial data. In many cities, drainage, access routes, or settlement extensions develop informally, and these strongly shape risk patterns. Participation can also refine hazard boundaries and terrain anomalies by showing where water actually accumulates or how local topography influences flow. Another major contribution is the mapping of social barriers to evacuation and maintenance. Physical accessibility is important, but social and behavioral barriers matter as well. Finally, participatory processes can incorporate indigenous or local risk memory, meaning collective knowledge about past events and recurring patterns. This kind of memory may reveal important long-term dynamics that are not visible in short-term datasets. Altogether, participation makes risk maps more precise because it adds fine-grained, context-specific information that formal models alone may overlook. At this point, the presentation shifts from mapping as analysis to mapping as a decision tool. The key message is that risk mapping must be embedded in formal procedures if it is to shape actual urban outcomes. This includes planning processes, environmental impact assessment, strategic environmental assessment, and budgeting. When risk maps are formally required in such procedures, they begin to influence zoning, infrastructure prioritization, and project evaluation in a systematic way. In Jakarta, risk mapping was used to define climate-sensitive zones and retreat areas, showing that maps can support difficult spatial decisions rather than just general awareness. This is a crucial shift. A map becomes meaningful when it affects where the city grows, what infrastructure is funded, which areas are protected, and how vulnerability is addressed. Therefore, the value of risk mapping lies not in its technical sophistication alone, but in its institutional integration. The decision-making framework presented here translates that principle into practice. First, the use of risk maps should be mandatory in all strategic processes, not optional or selective. Second, mapping should be integrated into existing workflows rather than created as a parallel system that policymakers ignore. This reduces institutional resistance and improves practical use. Third, unified interpretation manuals are needed so that different departments read and apply the maps consistently. Without guidance, the same map may lead to contradictory decisions. Finally, outputs for political leaders should be simple enough to support rapid decisions. Not every decision-maker will interact with raw GIS layers or complex models. Therefore, communication is part of the framework. The broader lesson is that effective decision-making depends not only on data quality, but also on procedural embedding, interpretive clarity, and user-oriented presentation. This slide introduces a simple but powerful cycle, from map to decision, from decision to action, and from action to learning. Maps first identify priority hotspots and vulnerable groups. Based on that evidence, decisions are made about suitable strategies such as zoning changes, infrastructure interventions, or social support programs. These decisions are then implemented through concrete actions, for example drainage upgrades, nature-based solutions, or mobility redesign. After implementation, the maps must be updated in order to assess impact and refine future decisions. This cycle highlights that resilience planning is not static. It is iterative and adaptive. Mapping does not end once a document is produced. Instead, it continues as part of monitoring and learning. In this sense, risk mapping becomes both an analytical tool and a management instrument, helping cities move from understanding problems toward improving outcomes over time. The next step is linking maps directly with action planning. This means that proposed measures should respond explicitly to the risks identified in the maps. A flood-prone informal settlement, for example, may require a different package of actions than an area facing subsidence-related infrastructure failure. Maps establish the geographic logic for prioritization by showing where different forms of intervention are most needed. They also enable before and after comparisons, which improves accountability and helps evaluate whether adaptation measures are actually reducing risk. In Jakarta, risk overlays were used to target multi-benefit interventions, meaning actions that could address several vulnerabilities at once. This demonstrates that maps are not only diagnostic tools. They are also design and policy tools that help organize interventions spatially, socially, and financially. Effective action planning therefore depends on a strong relationship between mapped evidence and selected measures. This slide provides a more detailed framework for linking maps and measures. The first step is to identify hotspots. The second is to assign interventions, which may be physical, socio-economic, planning-related, or nature-based. The third step is to evaluate feasibility, cost-benefit balance, and social acceptance. This is critical, because technically effective measures may fail if they are unaffordable or socially contested. The fourth step is to create resilience packages per zone, meaning that each area receives a coordinated set of responses rather than a fragmented project. Fifth, these packages must be linked to multi-year budgeting so that implementation becomes financially realistic. Finally, communities should be engaged in co-design. This last step reminds us that effective resilience cannot be delivered only from above. It must also be shaped with those who are most directly affected. The framework therefore combines spatial targeting, policy design, financial planning, and community engagement. The implementation framework for cities focuses on institutional coordination. Risk mapping requires collaboration across planning, water management, social services, and crisis units. Since risk is multidimensional, no single department can address it alone. A central GIS or data platform is also necessary to ensure interoperability and updates across institutions. Another important issue is role clarity. The presentation refers to RASCI, which helps define who is responsible, accountable, supportive, consulted, and informed. This avoids duplication and confusion during implementation. Legal anchoring is again emphasized, because without formal backing, risk mapping may be used inconsistently. Public communication is also part of implementation. Citizens need to understand why areas are prioritized, how decisions are made, and what resilience measures mean for them. In this way, implementation is not just about building projects. It is about creating a coordinated institutional environment in which risk-informed decisions can be applied systematically. To make implementation more concrete, the lecture proposes a phase model. The first phase is preparation, which includes establishing mandate, coordination structures, and a data inventory. The second phase is data integration, where hazard, exposure, and vulnerability are brought together. The third phase is participatory validation with communities, ensuring that mapped outputs reflect lived conditions. The fourth phase is resilience package formulation, meaning the design of targeted interventions for different zones. The fifth phase is budgeting and implementation, where plans are translated into financed actions. The final phase is monitoring, evaluation, and map updates. This phase model is useful because it shows that risk mapping is not a single task. It is a structured process that moves from governance setup to data work, community engagement, intervention planning, implementation, and learning. Such sequencing can help cities institutionalize resilience in a more organized and replicable way. Monitoring, evaluation, and adaptive management are essential because risks evolve over time. Hazard patterns may shift, exposure may increase through urban growth, and infrastructure performance may deteriorate or improve depending on investment and maintenance. Therefore, risk maps must be treated as dynamic tools rather than permanent documents. The presentation recommends monitoring hazards, exposure, infrastructure performance, and outcomes, and updating maps every 2 to 3 years or after major shocks. Jakarta provides a concrete example through the use of INSAR technology to track rapid subsidence trends. This is important because it shows how new data sources can support more adaptive risk governance. Monitoring and evaluation also make it possible to judge whether policies and investments are actually reducing risk. In this way, adaptive management connects mapping with accountability and long-term resilience learning. The presentation then summarizes the benefits of this approach for cities. First, it supports more efficient investment allocation, because resources can be directed toward the areas and systems where they are most needed. Second, it enables transparent and evidence-based planning, improving both legitimacy and effectiveness. Third, it allows fairer adaptation by targeting vulnerable populations more clearly, rather than assuming that all parts of the city face the same conditions. Fourth, it improves interdepartmental coordination by creating a shared evidence base and a common decision framework. Finally, it makes long-term risk reduction and resilience gains more measurable. These benefits suggest that risk mapping is not merely an analytical luxury. It is a practical tool that can improve how cities govern uncertainty, prioritize action, and build more just and resilient futures under climate pressure and urban transformation. In conclusion, the main message of this lecture is that risk mapping should be understood as a strategic governance tool rather than a technical add-on. It requires a mandate, integrated data, participation, and formalized procedures if it is to influence real outcomes. Jakarta demonstrates that even highly vulnerable cities can strengthen resilience systematically when mapping is embedded in decision-making rather than treated as a one-time study. The city's example shows that resilience depends on more than technical models. It depends on governance structures, political commitment, cross-sector coordination, and the ability to translate evidence into action. The final lesson is clear. Data-driven decisions can help create safer communities and more sustainable urban futures. But this only happens when mapping becomes part of how the city plans, invests, communicates, and learns over time.